Hello students, welcome to the Learner's Planet. Students, in this session we will be solving chemistry paper of 2010 and this will be our session 1, right? So let's start our problem solving session, students. Yeah, the first question was the standard enthalpy of formation of ammonia solid is minus 46 kilojoule per mole, right? If the enthalpy of formation of hydrogen from its atoms is minus 436 kilojoule per mole and that of nitrogen is minus 712 kilojoule per mole, the average bond enthalpy of NH bond in ammonia is. So what do you have to find out? You have to find out the bond energy of NH bond in ammonia, right? Now, we know the standard enthalpy of formation of ammonia, right? Now, for the formation of ammonia, what all other things required? First is the breaking up of hydrogen bond, that is the bond between two hydrogen atoms, and also the breaking up of the bond between two nitrogen atoms in the nitrogen molecule. Right? Now students, formation of a bond is an exothermic reaction, right? And for breaking up a bond, what you need is breaking up of a bond is an endothermic reaction, right? Now, so what will happen here? For the formation of ammonia, what all other things required? The hydrogen bond should be broken down and also the nitrogen bond should be broken down, right? Now let's take up the formation of one molecule of ammonia. So, for formation of one molecule of ammonia, or let's write the equation over here, that is N2 plus 3H2 gives what? 2NH3. Okay. Now, the bond energy between nitrogen atoms is how much? It is 712 and that is for the formation. So, for its breaking, what will be there? 712 kilojoule per mole plus the bond, the energy required for breaking up the bond between two hydrogen atoms would be, it would be 3 into, there are 3 hydrogen molecule over here and the energy for the formation of one molecule is 436. So 3 into 436, right? Now, the bond required, say for ammonia, you need to form a bond, right? So how many ammonia bonds are there? NH bonds are there over here. 6 NH bonds are there. So it would be 6x and that is equal to 2 into the enthalpy of formation of ammonia, right? So what is it? The enthalpy of formation of a substance is equal to what? The bond energy of the reactants minus the bond energy of the products, right? Now this is your 712 plus, what is it? It would be 3 into 436 and it comes out to be 1308 minus 6x is equal to 2 into 46 and that gives you minus 92, right? Now your 6x is equal to, what is it? 712 plus 1308. So 712 plus 1308 and minus, this is 712 plus 1308. So the 6x is equal to 2112. Right? So this is minus, and your x will be equal to what? 352. So how much of a bond energy is there for between NH bond in ammonia? It is 352 kilojoule per mole. Right? You can find it for 1 mole of ammonia also. Then it would be your 3x over here, this would be 1 by 3, and this would be 1. Right? So this was your question. So this was the marking scheme for this question was +4 and -1. If you're marking correct, it's +4, and if you're marking wrong, it's -1. Right? Now let's take up the next question, students. Yeah, it is. Now from which topic this question was? This was from thermodynamics. Now let's take up the next question. The time for half-life period of a certain reaction A to products is 1 hour. Right? So the products are formed from A and it is 1 hour. When the initial concentration of the reactant A is 2. Okay? So when the initial concentration is 2, the time is 1 hour. How much time does it take for its concentration to come from 0.5 to 0.25 mole if it is a zero order reaction? Right? So students, what is the equation for zero order reaction? It is your K is equal to A0 minus AT, and that is divided by the time. Right? So this is time. And now here, what is your A0 in the first case? Do we know K? We don't know it. We have to calculate time also. Can we find out K from the first this steps? Say what is written there. The half-life period of a certain reaction is 1 hour. Right? Now what is the equation for half-life period, students? The equation for half-life for zero order reaction is T half is equal to A0 by 2K. Now we can find out K from here. So what is the initial concentration given? It is 2. Okay, so it is 2, right? Now that is divided by, what is T half? That is 1. Okay, and into 2. So what is your K? K comes out to be 1, right? Now put this value over here. So it is 1 is equal to A0. Say what is it? A0 is 0.50 minus 0.25 divided by what? T. So how much time it is taking? It is 0.25 hours. Right? So this is taking 0.25 hours. So you can take it, this is also a half-life, right? So if you know the K over here, that is K is 1 and the initial concentration is 0.5, so what will be the half-life? That is divided by 2. That is also the simplest thing, right? So this question was from chemical kinetics, students, and the marking scheme was, this was from chemical kinetics. and the marking scheme was +4 and -1. Right? Now let's take up our next question.